Hello everyone, we are Jinghe Technology. In this video, we will continue to introduce the programming teaching of laser engraving machine. The previous video introduced the template production of QR code. After we check that the template is correct, we then save the template. We give this template a name. Let's write a name at random. Click Save. Then we click to close the panel editing window. Next, we started making the program. Next, we will load the template we just created into this program. We need to create a new program and select the template we just created. Find the template we just made. Here are 4 templates. Choose the template name AA of the previous video making. We chose this template. Click in. After selecting a template, click Open the AA template. So we've opened up the template, and here's what the template looks like. Then, we check whether the PCB length and width dimensions are correct. The length of the PCB is 300 mm and the width is 200 mm. Whether the barcode detection function is required. If you need to detect the QR code, select this function. We turn on this barcode detection function. Then select Engraving in the open area. This means that within the same field of vision, similar barcodes are also engraved at the same time. If not selected, the workhead will move once every time a barcode is engraved. Select Open, which means that as long as all the QR codes are engraved within the field of view of the camera, then move the working head. Then select Turn On to prevent secondary engraving. Then the other options don't need to be turned on. This is the QR code to identify after the engraving is completed. Then click Edit. At this moment, we need to place the PCB board at the entrance of the machine. After the PCB stops, click Collect Pictures. The machine will take pictures based on the length and width you enter. If you enter the wrong size, the captured image is incomplete. Next, we started making 2 marks. The first mark, we want to select a mark in the upper left corner of the PCB. We click the mouse in this position, and the working head will move over. If you need to move, we can click Move manually and drag the image. Click to move. We'd better place the mark in the center of the window. Don't drag marks into a corner, because the lighting effect in the middle is good. If there is no problem with the light, we will start making marks. If there is a problem with the light, we will first debug the brightness of the light. If we adjust the light brightness, we can only adjust the second light, because the second light is set for the mark brightness. The third is the light settings where the machine reads the QR code. If you move the total settings, all the parameters are moved together. If you need to debug separately, click this to expand. This is coaxial light, for tinplating. We need to adjust the contrast of the mark to be more obvious. The 4th channel has no light source and is used as a backup. General white oil or silkscreen printing is adjusted for 2 and 3 brightness. The first is mainly used for tinning PCB brightness. So let's turn up the 2nd and 3rd brightness a bit. After the brightness is debugged, click OK. Click OK. Click on Mark 1, then select the shape template. Click Mark 1 side, then click the other side. We shrink the blue box to the same size as the mark. Reduce the blue box to the size of the mark, just to wrap the mark. Then click the right mouse button. Next, let's debug the contrast. Let's check the mark, if the white mark is wrapped by the red thread. All the red lines are wrapped with white marks. We set the contrast to about 70 to 80. After the setup is completed, we click OK. We can also choose a different channel to try. We believe the parameters are more suitable, the contrast is better, and all red lines have been marked. We still choose the 3-color channel. This is the search range of marks. The blue box is the search range of the mark. This search area is a bit small and we need to expand it. Let's make this search range parameter larger. Both parameters are set larger. We checked all the parameter settings. There is no problem. We click OK. Next we make the second mark. In the PCB navigation diagram, click on the lower right corner of the PCB. We debugged the first mark light, so the second mark light does not need to be debugged. We click on the second mark, and the brightness of the light source will be automatically adjusted to be the same as the brightness of the first mark. Next, we center the mark position. Click to move manually. Just move to the center. Select the second mark and click on the shape template, then box the mark. Then click the right mouse button. Then we adjust the contrast and check that the circular red line wraps the white mark. Then set the parameters of this mark in the previous order. Debug contrast. Debug the search scope of the mark. If you set it wrong, you can click Cancel and reselect this mark. We click on the second mark and reframe the mark. If the second mark is set, it will be displayed here, as will the position of each engraving. After setting the parameters, click OK. There will be a second mark. Next, we make the engraving position of the QR code and where is the QR code placed. If your PCB board is a single large PCB without a puzzle, we only need to place the QR code in the designated area. If the PCB board is made of multiple PCBs, then we need to engrave the QR code on each board. In the PCB navigation diagram, click on the target location. We put the QR code on top of this white oil. Click on the QR code to move to the target location. Click on the white oil position. This places a QR code. If the number of QR codes is not large, we can place them manually. If there are many puzzles, we use the array method. We click the right mouse button to cancel the placement of the QR code. We introduce array placement QR code. We delete this QR code. After selection, press the delete key of the keyboard to delete. We select the first QR code and then proceed to array mode. Select the QR code and click Array. Let's count the number of PCBs, how many rows and columns we need to set up the array. We enter 9 rows into columns and then choose the best route. This route is the shortest. Engrave all the QR codes on the left first, then engrave all the QR codes on the right. Click OK. Then set the spacing. Then find the benchmark for the first puzzle. Set this point. Select this position as the first reference point and then click with the left mouse button. Once confirmed, move to the next location. Next, we need to click on the second point, which is the X distance, and we want to measure the X distance. We move in the direction of the X-axis. Select a point at the same position as the reference position. We select the second reference point in the PCB navigation chart. Yes, it's this location. We click this location. Then the task head will move to this position. We click on a second reference point at the same location, thus measuring the total distance of X. Then click on the last point in the Y direction to measure the total distance in the Y direction. We click on the PCB navigation diagram and select the last point in the Y direction. Also click on the same reference point location. After clicking, the QR code will be displayed. QR code array like this is already complete. If there is no offset problem in the position of the QR code, we will click Save and Engrave. We click Save this program. We will name this program. I named the program whatever I wanted. In offline mode, the ticket name is the same as the program name. This work order name is set according to customer requirements. Then click OK. The program is saved. Click OK. In order to ensure that the QR code location is accurate and there is no bias, we need to check. Since our QR code is arrayed, we'd better check if there is any offset. We click Edit to let the PCB array enter the machine once. Let the machine array identify the mark, check the location of the QR code. After the machine recognizes the mark, all QR code icons will be displayed. We click this button to check whether the position of each QR code is offset. No problem, click Next. If there is an offset problem, we choose QR code and use WASD on the keyboard to move. There is a blue dot on the mark, which means it has been selected. We click WASD to move. After moving, we click Next to continue checking. After the inspection is completed, click Save. If there is no problem in the inspection, we can click Save and start engraving. Click Save and click OK. Click to cover. Click OK. Then we closed the security door and were ready to start carving. Then we need to uninstall the PCB in the machine and place a new PCB. Since this machine is not connected to the machine behind it, this window pops up. Because the lower machine signal is not connected, the PCB stays at the exit position of the machine. We click No and the PCB stops at the exit of the machine. In the main interface, we find the Machine Start button. The machine will engrave the QR code while recognizing the QR code. You see, within the CCD field of view, engraving to QR codes at the same time. The PCB engraving is completed, and the PCB automatically flows out to the machine outlet. Let's check the effect of the engraving. Thank you for watching. The teaching of machine programming is over. If there is anything you don't understand, please contact www.jinghe.com.